What exactly is heat engine work output? Imagine a machine that takes heat from a hot place and turns it into motion or electricity. That's what a heat engine does. But what exactly is the work it produces? Let's find out. A heat engine's main job is to convert thermal energy into mechanical energy. It absorbs heat from a high-temperature source, like burning fuel or nuclear reactions. Then, it uses that heat to move parts like pistons or turbines. The work output is the actual energy the engine delivers to do useful tasks. For example, moving a car's pistons or spinning a generator's rotor. The process involves taking in heat, which we call Q in, from the hot reservoir. The engine then releases some heat, called Q out, to a cold reservoir like the surrounding air. The difference between the heat absorbed and the heat expelled is what we call the net work output. This is written as W net equals Q in minus Q out. This network is what powers machines or produces electricity. But not all the heat absorbed becomes work. Some energy is lost as waste heat because of inefficiencies and energy laws. The second law of thermodynamics says no engine can turn all heat into work without losing some heat along the way. The efficiency of a heat engine is a simple ratio. It's the net work output divided by the heat input. So, efficiency equals W net divided by Q in. This tells us how good the engine is at turning heat into useful work. If an engine has high efficiency, it wastes less energy. But real engines always have efficiencies lower than ideal models like the Carnot engine because of friction and heat losses. Understanding how much work a heat engine produces helps engineers design better engines. They aim to get the most work from the least heat loss. This concept applies to many devices like internal combustion engines in cars, steam turbines in power plants, and gas turbines in airplanes. Knowing the work output helps improve performance and save energy. In short, heat engine work output is the useful energy an engine gives off after converting heat into motion. It's the reason engines can power vehicles, generate electricity, and run industrial machines. It's a fundamental part of how thermodynamics guides the design and operation of all these systems.